Hello students, welcome all of you. In this video, I Abhay Kumar going to discuss a very important topic in classical mechanics, which is canonical transformation. For B.Sc. Part 3 Physics honors courses of all universities in lecture number 8 of classical mechanics. In canonical transformation, we can transform 4n plus 1 variables. 4n variables are a small qi, a small pi, capital Qi, capital P, and capital Pi. These are 4n variables. Two variables, a small qi, that is position coordinate, and a small pi, that is momentum coordinate in the old coordinate system, while capital Qi and capital Pi are the position and momentum coordinates in the new coordinates system, and one coordinate is time t. So total 4n plus 1 variables can be transformed into only 2n plus 1 variables. 2n variables from out of 4n variables, that is a small qi, a small pi in the new coordinate, in the old coordinate system, and capital Qi and capital Pi, that is position coordinate and momentum coordinate in the new coordinate system, and one variable is time. So in canonical transformations, in canonical transformation, 4n plus 1 variables can be easily transformed into only 2n plus 1 variables with the help of transformation equations given by equation 1, that is capital Qi is equal to capital Qi under bracket a small q comma small p comma time t, that is capital Qi is the function of a small q, that is position coordinate in the old coordinate system, a small p, that is momentum coordinate in the old coordinate system, and time t, and pi, capital Pi is the momentum coordinate in the new coordinate system, and it is equal to pi is the function of a small q comma small p and time t. And both transformation equations are represented by a single, that is the set of two transformation equations related to position coordinate Qi in the new coordinate system and momentum coordinate Pi in the new coordinate system by a single equation given by equation number 1. If there exists a Hamiltonian capital K in the new coordinate system such that Pi dot, that is dpi upon dt, that is rate of change of momentum, Pi dot is the rate of change of momentum, that is dpi by dt equals to minus del k upon del Qi and capital Qi dot, that is rate of change of position coordinate, which is equal to dqi upon dt. Qi dot can be represented as dqi upon dt equals to delta k, that is del k upon partial differentiation del k upon del pi, and suppose it is equation number 2. The transformation for which these equations 2 are valid are known as canonical transformations. Capital Qi, that is position coordinate in the new coordinate system, and capital Pi, which is the momentum coordinate in the new coordinate system, are known as canonical coordinates. They must also satisfy the Hamilton's principle, which is given by delta integral T1 to T2 L dt, that is time integral of the Lagrangian, equals to 0, which is the Hamilton's principle. Delta integral T1 to T2 L dt is equal to 0, where T1 to T, where integral T1 to T2 capital L dt is the time integral of the Lagrangian. So Hamilton's principle is delta, symbol delta, integral T1 to T2 L dt equals to 0. So capital Qi and capital Pi, which are known as canonical coordinates, capital Qi is the position coordinate and capital Pi is the momentum coordinate in the new coordinate system, and both are known as canonical coordinates, and they must also satisfy the Hamilton's principle given by delta, symbol delta, integral T1 to T2 under bracket sigma k Pi, capital Pi into capital Qi dot minus capital K, which is the function of capital Q, capital P, and time t, bracket closed, and also big bracket is also closed, multiplied by dt. Out of the bracket it is dt is equal to 0, where in place of Lagrangian in the new coordinate system, that is L bar equals to sigma I Pi Qi dot minus k. So in the Hamilton's principle, delta integral T1 to T2 L dt is equal to 0. Here L is replaced by L bar, that is Lagrangian, in the Lagrangian function in the new coordinates system, and we know that Lagrangian L is equal to sigma over k pk qk dot minus h, where h is the Hamiltonian in the old coordinate system. So using that formula, in the new coordinate system, Lagrangian can be represented by L bar, capital L bar equals to sigma over I Pi Qi dot minus capital K, and it is the Lagrangian in the new coordinate system. The old coordinates, a small pi, that is momentum coordinate, and a small qi, which is the position coordinate, are already canonical. Therefore, again using the Hamilton's principle for the old coordinate system, delta in the old coordinate system, for old coordinates, we have delta, symbol delta, integral T1 to T2 under big bracket sigma I, a small pi, multiplied by qi dot minus capital H. Capital H is the Hamiltonian function in the old coordinate system, and it is the function of position coordinate, a small q, in the old coordinate system. A small p is the momentum coordinate in the old coordinate system, and time t, bracket closed, big bracket is also closed, multiplied by dt. Dt is out of the bracket and is equal to 0. And suppose say it is equation number 4, where Lagrangian function in the old coordinate system is capital L is equal to sigma over I, a small pi qi dot minus h, capital H, which is the Hamiltonian function. H is the Hamiltonian function in the old coordinate system, while capital K is the Hamiltonian function in the new coordinate system. Now equations 3 and 4 are simultaneously valid if the integrands of both equations, that is equation 3 and equation 4, differ by the total time derivative of an arbitrary function capital F. That is, we can write the difference in the integrands of two equations or two integrals given by equations 3 and 4, that is sigma over I pi qi dot minus h, that is in the old coordinate system, minus pi qi dot minus k, that is in the new coordinate system, and these are difference of two integrands in equation 3 and equation 4, or integrals given by equation 3 and equation 4. And the difference of two integrands, that is sigma over I pi qi dot minus h, bracket closed, minus under bracket pi qi dot minus capital K, and this must be equal to the total time derivative of an arbitrary function capital F, say capital F, that is df upon dt. df by dt is the total time derivative of an arbitrary function capital F. So we have under bracket sigma over I pi qi dot minus h, bracket closed, minus under bracket pi qi dot minus capital K equals to df upon dt. And in that case, both equations given by 3 and 4 will valid simultaneously if this condition given by equation 5, that is under bracket sigma over I pi qi dot minus h minus under bracket pi qi dot minus k equals to df by dt is fulfilled. Or using Hamilton's principle, we can write delta, symbol delta, integral t1 to t2 under bracket sigma over I is equal to 1 to n pi qi dot minus h, that is integrand of equation 3 differ by the integrand of equation 4, that is minus sigma over under bracket sigma over I is equal to 1 to n capital pi qi dot minus k, bracket closed, into dt is equal to 0. And in place of the integrand of equation 6, that is sigma over I is equal to 1 to n pi qi dot minus h, bracket closed, minus under bracket sigma over I is equal to sigma over I equals to 1 to n pi qi dot minus k, and this difference may be written as df upon dt using equation 5. So we can write in equation 6 delta integral t1 to t2 df upon dt into dt is equal to 0, and using the rule of different integral, finally we can write delta under bracket capital F is a function of t2 minus capital F t1, taking upper and lower limit, that is difference of upper and lower limit, ft2 minus ft1 under bracket equals to 0, and say it is equation number 7. This is the final expression, and the function which is which is we have taken a new arbitrary function capital F, and this function capital F is called the generating function of the canonical transformation. कैपिटल एफ को कैनोनिकल ट्रांसफॉर्मेशन का जनरेटिंग फंक्शन कहा जाता है. द फर्स्ट ब्रैकेट ऑफ इक्वेशन 5 is regarded as a function of a small qi, a small pi and t, that is position coordinate a small qi, momentum coordinate a small pi in the old coordinate system and time t, while the second second bracket of equation 5 is as a function of capital Qi, capital Pi and time t. Capital Qi is the position coordinate in the new coordinate system. Capital Pi is the momentum coordinate in the new coordinate system, and t is the time. So first bracket of equation 5 is the function of a small p, a small q, that is pi, qi and t, while the second bracket is the function of capital Pi, capital Qi and t, that is the generating function capital F is in general a function of 4n plus 1 variables. That is 4n variables are a small qi, a small pi in the old coordinate system, and 2n variables capital Qi and capital Pi in the new coordinate system, that is 4n variables, q, a small qi, a small pi, capital Qi and capital Pi. These are 4n variables, and one is time t, that is the generating function capital F in general a function of 4n plus 1 variables, but with the help of equation 1, that is transformation equations given by equation 1, that is capital Qi and is equal to Qi is the function of q, p and t, and capital Pi is the function of capital Pi is equal to Pi is the function of q, a small p and t. 4n plus 1 variables can easily be transformed or reduced to become the function of 2n plus 1 variables. 2n variables, out of which one variable is t, time t, and other 2n variables are taken from a small pi, a small qi, capital Qi and capital Pi. तो 2n वेरिएबल्स हम ऑब्टेन कर सकते हैं. टोटल 4n वेरिएबल्स, a small qi, a small pi in the old coordinate system, and capital Qi and capital Pi from the new coordinate system. Sorry. So with the help of transformation equations given by equation 1, we can reduce total variables, that is 4n plus 1 variables, that is from equation 5 it is clear that the generating function capital F is the function of 4n plus 1 variables. But with the help of transformation equations given by equation 1, we can reduce 4n plus 1 variables into 2n plus 1 variables. That is generating function capital F may be reduced to become the function of only 2n plus 1 variables using equation number 1, that is transformation equations given by equation number 1. Thus, thus there are four forms of generating functions. Capital F1, which is the function of generating function. Capital F1 is the function of a small q, capital Q, and time t. A small q is the position coordinate in the position coordinate of the old coordinate system, while capital Q is the position coordinate in the new coordinate system, and time t, that is total. F1 is the function of 2n plus 1 variables, while F2, second generating function F2, it is also the function of 2n plus 1 variables, that is F2 under bracket is the function of a small q, capital P, and time t, that is 2n plus 1 variables. Third generating function F3 is also regarded as the function of 2n plus 1 variables, that is F3 is the function of a small p, capital Q, and time t. And the last generating function, that is fourth generating function F4 is the function of a small p, capital P, that is momenta in the old coordinate system, a small p, and momentum in the new coordinate system, capital P, and time t. Thus, the fourth generating function F4 is also can be regarded as the function of 2n plus 1 variables, that is F4 is the function of a small p, capital P, and time t. Now for these four generating functions, capital F1, capital F2, capital F3, and capital F4, which we have discussed, the following canonical transformations, that is canonical transformation equations, can be obtained by using Legendre transformation rule. For the generating function capital F1, that is the first generating function F1, which is the function of a small q, that is position coordinate in the old system, capital Q, that is the position coordinate in the new coordinate system, and time t. Pi, a small pi, equals to del capital F1 upon del Q1, comma capital Pi, that is momentum coordinate in the new coordinate system. Pi, capital Pi, equals to del capital F1 upon del capital Qi. Qi is the position coordinate in the new system, and capital K, that is capital K is the Hamiltonian in the new coordinates system. So capital K is equal to capital H, that is Hamiltonian in the old system, plus del capital F1, which is the capital F1 is the first generating function. So del capital F1 upon del t. And this represents a set of transformation equations for the generating function for the first generating function capital F1. Now for the second generating function capital F2, which is the function of a small q, capital P, and time t. Capital P is the momentum coordinate in the new system, a small q is the position coordinate in the old system, and a small t is the time. So for the second generating function, capital F2 is the function of a small q, capital P and T. We have, that is, transformation equations are a small pi equals to del capital F2 upon del qi, then capital Qi equals to del capital F2 upon del pi, del capital Pi, and Hamiltonian in the new system for the generating function F2, that is the second generating function, capital K is equal to capital H plus del capital F2 upon del T. That is a set of canonical transformation equations for the second generating function, capital F2. Now for the third generating function, capital F3, which is the function of a small p, that is momentum coordinate in the old system, comma capital Q, that is position coordinate in the new system, and time t, that is F3. The third generating function F3 is the function of a small p, capital Q, and time t. And for this generating function, that is for the third generating function, the canonical equations are, that is the canonical transformation equations are a small qi equals to minus del capital F3 upon del a small pi, comma capital Pi equals to minus del F3 capital F3 upon del capital Qi, and Hamiltonian in the new system for the third generating function F3 is given by capital K is equal to capital H plus del F3 upon del capital F3 upon del T. This is the third set of canonical transformation equations. And for the generating function F3, that is for the third generating function F3, and finally for the fourth generating function, capital F4, which is the function of a small p, that is momentum in the old coordinate system, capital P, that is momentum in the new coordinate system, and time t, that is the fourth generating function, capital F4 is the function of a small p, comma capital P, and time t, that is 2n plus 1 variables. And the set of canonical transformation equations are a small qi equals to minus del capital F4 upon del a small pi, comma capital Qi equals to del capital F4 upon del capital Pi, and the Hamiltonian in the new coordinate system for the generating function F4 is given by capital K is equal to capital H plus del capital F4 upon del T, where capital H is the Hamiltonian function in the old coordinates system. So this is the final set of canonical transformation equations for the fourth generating function, capital F4. Suppose these four sets of canonical transformation equations for all four generating functions, capital F1, capital F2, capital F3, and capital F4 is represented by, that is the four sets of canonical transformation equations for the four generating functions is represented by, say it is equation number 8, and it is the last equation. Now this video is completed. यदि यह वीडियो आप सभी को पसंद आया हो तो इस वीडियो को अधिक से अधिक लाइक करें तथा मेरे यूट्यूब चैनल फिजिक्स क्वांटम क्लासेस को अधिक से अधिक सब्सक्राइब करें. थैंक्स ऑल ऑफ यू फॉर वाचिंग माय यूट्यूब चैनल फिजिक्स क्वांटम क्लासेस.